Hello, welcome to Master CFD Geometry and Mesh Generation training video. In this video, I want to teach you how you can draw the geometry and create the mesh for this project. At first, if I want to say that about the pipe bending, actually I can say that many industries rely on bent pipes to transport, deliver and refine products and streamline operations. For instance, bent pipes are widely used in the plumbing, automotive, aviation, shipbuilding, aerospace and oil and gas industries. And about what's pipe bending? Once a pipe has been fabricated, it typically undergoes several post-fabrication processes to turn it into a usable product. Pipe bending is one of them. Pipes can be bent manually using a bending clamp or by specialized machines that have been calibrated to bend a pipe into a specific shape. Additionally, pipes can be cold or induction bent. Cold bending is performed by bending a pipe at room temperature, and this process is usually done by wrapping the pipe around the desired shape. On the other hand, induction bending is performed by hitting a small section of pipe with an induction coil while continuously applying mechanical force to cause the material to bend. Both methods have advantages and disadvantages. About the bent pipe uses, actually bent pipes serve various purposes. For example, large and small diameter pipes are installed on large ships to transport fuel, water, oils, and gases. Moreover, various pipe bending techniques are employed in the automotive industry to shape the components in a car body, a chassis, engine, and exhaust systems. Pipe bends are also required to make handrails, bicycle racks, and larger structures like bridges and oil and gas pipelines. This only scratches the surface of possibilities. Open the ANSYS Workbench software, double-click on the geometry under the component systems to create this block, and then double-click on the geometry to open the ANSYS Space Claim software. The default unit in the software is millimeter. Before drawing, I want to set the unit to centimeter. Follow my cursor point here in the Space Claim options. Click on the units and in front of a length, change the millimeters to centimeters and then click on the OK. Here, click on the x-axis and then under the sketch tools, use the circle. Click on the screen and drag to create a circle. And the diameter of the circle is equal to 3 centimeters. Click on the end sketch editing and then create a plane on this sketch. Then move this plane in the x-axis direction 50 centimeter and then draw a line, and the length of this line is equal to 50 centimeters from the center to this plane and this line. You can see that you have to specify both the angle and the length for this line. You can switch between these two sizes using the tab key on the keyboard. Now, I want to turn this circular cross-section into a 3D volume on the path I have drawn with lines. Select the circle and then using the pull tool, choose the path and then click on the play icon. You can see the 3D volume of the circle cross section, and this is the final geometry. Here, enable the plane in the Structures tab, and then under the workbench, click on the Share to prepare this geometry for the ANSYS Meshing software. In the last step, here, click on the Save As, and here specify the path that you want to save your geometry, and choose the format. For example, here I choose the TP format, and then click on the Save. Back to the ANSYS Workbench software, double click on the mesh under the component systems, and then drag the geometry from the geometry block and drop it to the mesh block, and double click on the mesh to open ANSYS Meshing software. Here, change the physics preference to the CFD and set the element size to this value, and smoothing to high, because I want to generate a mesh with a high quality. And then, as can be seen, this is the structure mesh on this geometry. I want to change the mesh to unstructured. Right click on the mesh, choose the method, and here set the method to tetrahedrons. Then click on the generate to create a new mesh. To create a boundary layer mesh, right click on the mesh, inflation, choose the geometry, and then set the boundary to create the boundary layer mesh. These surfaces, and inflation option, use first layer thickness and set the first layer height to then maximum layers and growth rate, and then click on the generate. In this step, you need to name the boundaries so that when the mesh enters the Fluent software, you can set the boundary conditions. The surface is inlet. These surfaces are walls. Also, for this body, flow. In the last step, you must export the mesh for the Fluent software. Here, specify the path and then the mesh file, and click on the Save. To benefit from Master CFD services, including simulation, consultation, and training, visit our website www.master-cfd.com. Contact us via info@master-cfd.com.